8.1, client and server programming. Yeah. So in this part, we will look at the overview, general information about client-server programming. Yeah, just some basic environment. Yeah. All right, part B.1, server-side architecture first. In the 8.1, I, introduced the basic three-tier architecture, right, containing client-side, server-side, and database. Yeah. But in those three tiers, the server side is the most important. So that's the reason I use another one whole video to talk about server-side architecture. More details. Yeah. All right, so let's look at this topic. First, I'd like to give you a little bit network basics, because in order to talk about communication, we need to know a little bit network basics. Yeah. So in this picture, we saw it before in our first video, part 8.1, we saw this already. Yeah. But here, let us look at a little more. Mainly, we will want to look at the network related information. Yeah. The first question, how to identify a server. Yeah. In order to send a request to a server, we know a client starts a communication cycle by sending a request to the server. The question is, how do you identify a server, right? So you need to do some basic things to identify the server. First, there is some special address needed. You need to know the address of that server. Yeah, that server has a unique address. So you can, use that address to locate that server. Yeah. So what is that address? Yeah. So many of you may know that. Yeah. So that is the IP address. Yeah. IP address. Okay. Yeah. IP here means Internet Protocol. Internet Protocol. Okay. Some low-level protocol, right? IP. Okay. Yeah. Remember, I mentioned a little bit some protocol before. TCP/IP, right? So you may have heard of that. So many times people talk about TCP/IP low-level protocol. So for the networking basics, that protocol is the foundation. Yeah. And here, we use this Internet Protocol IP address, this concept. All right, so it is unique code identify a piece of equipment connect to a network. Yeah. If you want to make one equipment to be identified in the whole big, huge internet, you need to assign it an IP address. So here, we need to have a little basic information about IP address. Okay, yeah. There are two types of IP addresses. Yeah. The first type, the old type, people used a long time ago, the old type, IPv4, version 4, IPv4. Yeah. So it's just a 32-bit number. 32-bit number. Okay, 4 bytes. We know 1 byte corresponds to 8 bits. 32. So 4 bytes. So it's relatively short. Okay, 4 bytes. Okay, 4 numbers. Each number corresponds to a byte number. Yeah, we know one byte number corresponds to small integers, right? How small it is from 0 to 255. Okay? 4 such small integers are used to represent one piece of equipment on the internet. Those 4 numbers are separated by dot operator, dot. Okay? The first number, dot, using dots separate them. Second number, dot, and so on. Okay? Yeah. So you can see here, these little numbers, here, right? Yeah, little numbers. Yeah. 4 numbers in the range from 0 to 255 separated by dots. Okay, so later we have a name for it. Okay, dot decimal representation. Dot, first we use dot to separate these numbers. Then each one we use the decimal representation. Decimal. Okay, because we may have other numeral system representations, right? Here we emphasize the decimal representation because later we will change to other, for example, hexadecimal representation, right? Hexadecimal representation. Yeah. So that's why this one we call it dot decimal representation. Yeah. The second type, IPv6. That's the relatively new one, but we are using it also. Yeah, actually, in the current technology, people use both IPv4 and IPv6 mixed. Yeah. Okay, but the IPv6, you can see it is much larger. For the number of bits, you can see 128-bit number. That many. So how many bytes? So you can do the calculation, right? Yeah. 8 divided by 8. Yeah. Each byte. Oh, but here, yeah, the reason is because IPv6, we need this many bits, 128 bits. So we will not use the dot decimal representation. Yeah, because that's, not very efficient. If you use it, you need too many numbers. The structure-wise, not easy to handle. So you need to have a better way to handle it. So we will use hexadecimal representation. The separator won't be dots. The separator will be colons, using colon to separate. So you will get colon hexadecimal representation. Yeah. So we will see that in later some video. I will talk about that. Yeah. Although the structure much more complicated, but I just give you some basic information about IPv6. Yeah. So you need to know just a little more information. Yeah. But we will not go much deeper. Yeah. So we don't want to spend too much time on it. Yeah. All right. So next, regarding the number of IP addresses for IPv4, you can see that number not very big, just a little more than 4 billion. Okay, here you can see this number 2 to the 32. That power of 2, okay, 2 to the power of 32, that number, a little more than 4 billion. So nobody feel that many IP addresses are sufficient for current internet applications. No. So that's the reason we need much more different IP addresses, resources we need. So that's the reason we need much larger, possibilities for the new version of IP address, IPv6. Yeah. Now let's look at how many of IPv6 addresses we can have. This many. 2 to the 128th power. That big. How big is that? 3.4 times 10 to the 38th. That big number. So what's that number? Yeah, it is hard to use an appropriate name to call it. Yeah. Here, this name. Have you heard of it? Yeah. 340 undecillion. I haven't heard of this undecillion before. Yeah, I never heard of people talk about that. Too big, undecillion. Yeah. We heard of trillion, right? Yeah. Zillion even. Yeah. Zillion, trillion. But never heard of people talk about undecillion, right? Yeah. That big number. Yeah. Anyway, yeah. Now, this time, remember, this diagram I showed you in video part 8.1, but at that time, I felt we may not have enough background knowledge to understand this diagram better. So here, now, I think we can understand it much better. Yeah. All right. 3-tier architecture. Yeah. Tier number 1, the client side. That's easy. So I do not need to spend much time to talk about that. And the tier number 3, database side. Also relatively easy. Yeah. Now the hard part is tier number 2. We call it business tier or middle tier based on the position. We call it middle tier. Based on its functionality, we call it business tier. So mainly people implement business rules in this tier. So that's the reason people call business tier. Okay, so we implement business rules in this tier. Okay. Yeah. All right. So, but here, let me give you the, communication details between client and server, going through request and response in a whole communication cycle. Yeah. Here you can see these little numbers, 1, 2, 3, 4, those numbers telling you the communication steps. Step 1, 2, 3, 4. Let us just use those step numbers following the, step number order. We understand the communication details. Yeah. All right. 1, so that is a user starts communication by submit a request. Type URL of a server. Hit enter. That starts communication. Request is sent to a server. All right. Send first. Go through internet. Yeah, that request goes through internet infrastructure. Okay, yeah, and then the first reach the web server. Here you can see in this tier number 2, there are 2 layers. Inside tier number 2, there are 2 layers. Yeah. So let me call it A layer and B layer. Okay. Yeah. Because in the little notation you can see 2A, 2B, right? So A sublayer, B sublayer. Now, so what is the A sublayer for? Yeah. A sublayer provide simple, relatively simple, we know, simple static services. Yeah. Definitely static included. Okay, static included. Yeah, because static we treat as simple. Okay, simple could also be dynamic. Simple dynamic type services. Okay, so some data manipulation. So dynamic, we know we can do some data manipulation, but not too complicated. Okay, yeah, we don't want to do too complicated dynamic manipulation. Yeah, if too complicated, we leave to the second layer. Okay, the B layer, B sublayer. Yeah, all right. So relatively simple. So here you can see why this cylinder it put CSS images, pages. It tells you first static resources, right? So here mainly static resources. Okay, yeah. But this layer can also do some simple dynamic services. Yeah, so it's okay. Yeah. All right. Then part B layer, sophisticated dynamic resources. How sophisticated? Here I cannot give you examples. I cannot. Because you can imagine in big companies, usually, large scale corporations, corporate, large, we call it enterprise. We call enterprise level corporations. Yeah. For that kind of big companies, they require very complicated, sophisticated, data services. Okay, data services. In the first video, I use heavyweight, right? Remember, the layer A, I use lightweight. Layer B, I use heavyweight. Okay, yeah. So here, so you can see, then only when you need to use the heavyweight business services, then you use layer B. Yeah. So the request is sent to layer B to get that kind of, expensive business services. So usually that kind of services, takes a lot of money, consumes, a lot of resources, a lot of money, things like that. All right. So after that, you may, when you do the services there, you may need to access database. Actually, layer A, if you want to access database, it's also okay. Okay, you're allowed to access database from layer A, so it is fine. But you can see from our diagram, from this diagram, you can see the only part that the application can access the database is this one. See, step 4. You do not see from layer A to database, right? Although I draw that part. Let me explain a little more regarding this diagram. Although technically there is no problem from layer A to database layer. Now technically there is no problem, but in reality, most companies, when they use this double middle layer architecture, the middle tier has double layer. This architecture, this special architecture, most big companies, when they use this architecture, they also use the layer A as the security layer. Okay? So they, just like a wall put in front of their, backyard, that kind of thing. Okay? Protect their, important, the business related resource behind it. So most companies, when they use this kind of double layer middle tier architecture, they use the layer A as the protection layer. Okay? So since they use it as a protection layer, so they intentionally, they do not make layer A to access database. Now, although technically no problem, but they try to avoid that. Okay? In this way, they try to make their whole web application more secure, better protection, that kind of consideration. All right. So here I just emphasize that part. Then, based on that understanding, you can see the step 4 only application server, the back layer of business tier. That's the back layer, not the front layer. So you can see the business tier is divided into 2 layers, the front layer and the back layer. Then only the back layer is used to access their critical business data. Front layer for protection. So in this way, so we try to understand the structure, architecture better. All right, so let me finish part B.A right here.